After 15 years and $500 million, the US shelved the electromagnetic railgun, claiming the barrels melted and the power bills were too high. But the Pentagon doesn't just throw away $500 million of physics. They strip the railgun's magic bullets, the hypervelocity projectiles, and stuff them into standard 5-inch guns, achieving Mach 5+ speeds across the existing fleet. The real power play, the Gerald R Ford-class carriers. These $15 billion giants produce 3 times the power of any previous ship, feeding the hunger of 600 kilowatt lasers that vaporize threats for $1 per shot. The math is finally on our side. Let's dive in. The $85,000 bullet, railgun tech in a powder gun. The US Navy didn't actually abandon the railgun, they just stripped it for parts. The most valuable piece was the hypervelocity projectile, a magic bullet originally designed to survive the insane electromagnetic forces of a railgun barrel. When the railgun program stalled, engineers realized they could launch this same sub-caliber projectile using the standard Mark 45 5-inch guns already found on every Arleigh Burke-class destroyer. The secret is a specialized 5-inch sabot, a segmented casing that captures the expanding gases of a traditional powder charge to catapult the projectile to hypersonic speeds of Mach 5+. Upon exiting the muzzle, the sabot separates into 4 pieces, leaving the low-drag HVP to streak toward its target. But this isn't just a dumb artillery shell. The HVP is a gun-launched guided projectile, featuring an onboard processor and 4 maneuverable fins for terminal guidance and high-G course corrections. Linked to the ship's precision fire control architecture, the HVP receives high update rate telemetry to calculate intercept trajectories for high-speed threats like cruise missiles and sophisticated drone swarms. Here is the front cost math that changed the Pentagon's mind. A standard interceptor missile like the SM-6 can cost over $4 million. In contrast, a single HVP round is estimated to cost roughly $85,000. In August of 2024, during the major sea trials with the USS Jason Dunham, the Navy proved that this hidden railgun tech could effectively neutralize aerial threats at a fraction of the cost of a missile. By firing at a rate of 16 to 20 rounds per minute, a single destroyer can now throw up a hypersonic wall of guided lead. It is a low-cost solution to a high-cost war, allowing the Navy to save its expensive missiles for the biggest threats while the HVP handles the swarm. The carrier's last stand, the A-1B power play. The biggest hurdle for high-energy weapons has never been the gun itself. It's the power bill. To fire a laser strong enough to melt a missile, you need a floating power plant. This is the power gap, and the Gerald R. Ford-class aircraft carriers were built specifically to erase it. At the heart of these $15 billion giants are 2 Bechtel A-1B nuclear reactors. These aren't just engines, they are the most dense mobile power sources ever conceived. While the exact thermal output is classified, we know the A-1B represents a 25% increase in power over the previous generation. But the real breakthrough is in the electricity. The A-1B plant is designed to provide approximately 3 times the electrical power of the Nimitz class. We are talking about an estimated 150 megawatts of electricity per reactor, a combined 300 megawatt punch that can power a small city. This massive electrical reserve is what allows the Navy to host power-sucking systems that would literally black out any other ship. Systems like Project Meteor, a high-power microwave weapon designed to fry the electronics of incoming drone swarms and anti-ship ballistic missiles, are scheduled for shipboard integration as early as fiscal year 2026. Because the Ford class was designed with the future in mind, it currently utilizes only about half of its planned electrical power for its current systems, like the electromagnetic aircraft launch system. That leaves a 50% power margin reserved for the next generation of warfare. It's an inexhaustible battery for a 600 kilowatt laser umbrella that can engage targets at the speed of light for about $1 per shot. When the enemy sends a $1 million saturation attack, the Ford doesn't just defend itself. It wins the economic war by using a battery that never runs dry. The carrier killer paradox, neutralizing the DF-26. For over a decade, the carrier killer has been the ultimate bogeyman of the Pacific. China's DF-21D and DF-26 ballistic missiles are designed to do one thing: scream through the atmosphere at Mach 10, and sink a $15 billion U.S. aircraft carrier from 2,000 miles away. For a long time, the only defense was a $4 million SM-6 interceptor. The math was simple. If China fires 50 missiles, the U.S. runs out of interceptors before the carrier even gets into range. But the integrated shield just flipped the script. The Navy is now testing a layered intercept strategy that starts with the hypervelocity projectile. Because the HVP is so small and fast, a single destroyer can fire a cloud of these $85,000 rounds into the path of an incoming ballistic missile. Instead of one expensive missile trying to hit one target, the HVP creates a hypersonic wall of metal that shreds the DF-26's guidance systems before it even reaches its terminal phase. And if anything leaks through, that's where the 300 kilowatt to 600 kilowatt lasers come in. At the edge of the carrier's strike zone, these lasers don't need to melt the entire missile. They just need to heat the nose cone for a fraction of a second. At Mach 10, even a tiny amount of thermal deformation causes the missile to tear itself apart under the sheer force of the atmosphere. We are seeing the transition from reactive defense to systemic dominance. The US isn't just trying to survive the DF-26. They are making the most expensive missile program in Chinese history as useless as a wooden arrow. The 2030 horizon, the return of the dreadnought. If the Ford class is the battery, the DDG is the gun. This is the Navy's next-generation destroyer, designed to replace the aging Arleigh Burkes by the early 2030s. But look closer at the design. It's not just a bigger ship, it's a floating energy platform built to solve the power gap that killed previous high-tech weapons. The DDG utilizes an integrated power system that can divert massive amounts of energy from the propulsion drive to the weapon arrays in milliseconds. We are talking about the capacity to host dual 600 kilowatt lasers and the Project Meteor high-power microwave system simultaneously. This creates a system of systems where the HVP handles long-range kinetic intercepts, while the lasers and microwaves create a speed-of-light kill zone for anything that gets close. But here is where it gets speculative. In the black budget shadows, there is talk of the BBG, a guided missile battleship concept for the late 2030s. This wouldn't be a ship with big cannons, but a directed energy dreadnought carrying massive 1 megawatt laser arrays. These weapons are intended to burn through the heat shields of incoming hypersonic glide vehicles from hundreds of miles away, acting as a final, impenetrable wall of defense. The era of the unlimited magazine is arriving. By the late 2020s and early 2030s, the U.S. Navy plans to have a fleet where the cost-exchange ratio is finally inverted. While the world's navies are currently forced to expend multi-million-dollar missiles to neutralize low-cost drones, the DDG and its successors will be spending pennies on the dollar. In the 2030s, the side with the cheapest bullet won't just win the battle, they will bankrupt their enemies before the first shot is even fired. The U.S. Navy didn't fail at the railgun. They just realized that the future of war isn't about the biggest explosion. It's about the best math. While rivals try to build faster missiles, the US is building a world where missiles don't matter. Because you can't outrun light, and you can't outspend a weapon that costs $1 a shot. If you want to stay ahead of the technology that's redrawing the maps of the Pacific, you know what to do. Subscribe to Front Cost. Hit the bell. Because when the lasers start firing, you'll want to be on the side that owns the battery. We'll see you in the next briefing.